All right, welcome back to Plain and Simple Projects. Today we're talking about ham radio. A little bit different than our usual topic, but I think there's definitely some value there. And so the presentation I'm making today is just a beginner's introductory guide. There's so many other resources out there with people so much more qualified than I am, but I'm just sharing a few of the things I've learned over the last couple of months as I've been studying ham radio. It's really fascinating, and to me, there's a lot to it. There's a lot of parts of it that are all over the world. It's really kind of amazing. So anyway, let's go and get started. So what is it? As I did the research, no one actually knew where it came from. It's fairly debated where a ham radio, the term ham, came from. Some people have said it comes from one of the manufacturers of radios, or it comes from kind of a derogatory term towards amateur radio operators. But nonetheless, it's basically what's used today to describe amateur radio operators. And back in the day, originally, all radio operators were amateur since it wasn't developed yet. And so it was actually amateur radio operators who developed the technology sector that we have today. This slide here, this really kind of demonstrates the complexity of the radio spectrum. This is in the United States. All these different colors are different uh, allocations of radio frequencies to different parts of industry, whether it's aerospace, whether that's television, or whether it's cell phones, or whatever it is that is using bandwidth on the radio spectrum. This kind of covers how that's broken down. A little bit of a blown up view of this in the radio traffic system. Have a closer look. And you can kind of see how, with each of these different frequency bands, like 30 megahertz, and then how that's divided up between different things. You can see the green box is actually amateur. So amateur is scattered throughout almost the entire spectrum on standard radio frequencies. And a lot of times, before a radio frequency is given out to industry, it's actually given to amateur radio operators, and they're usually the ones who develop it and develop the technology to use those particular frequencies. So like the higher gigahertz frequencies, there used to be a lot of amateur bandwidth up there before industry really figured out what to do with that bandwidth. And now we use it for, wireless routers or cell phones or all those kind of things that we use today. So it's kind of interesting to see how they've broken this down, and how each of these segments is kind of given to different parts of the industry. So we have broadcast television, land, mobile, a lot of different things, meteorological, depending upon the need. So anyway, kind of fascinating how they break that down. So the FCC, the Federal Communications Commission, is what governs the use of radio frequencies in the United States, and most countries have a comparable governing body that governs their use of radio frequencies in their countries. And then there's an international group that comes together to create international rules that kind of bring all the rules from the different countries together, because radio frequencies often go beyond borders. So the FCC, for our purposes in the United States, covers rules and licensing. And the radio license, as far as the FCC is concerned, is broken down into 3 sections. And there used to be a couple of different ones before, about 20 years ago, and they started to change this. But the first one is technician, which is mostly short range, which is VHF or UHF communications. There's some HF bandwidth that's allowed to be used by the technician radio licenses. It used to be that the technician radio licenses actually needed to know Morse code, but that was changed a while back, and it's just 35 questions. It's a pretty easy test. All the questions are available, and not too difficult. The general radio license, a little bit more difficult, and includes almost all the frequencies, including most of the HF. And it's also a 35 question test, but it is more difficult. Then following that is the amateur extra, and this is all the privileges. This is the highest level of licensing someone can get in the amateur sector. and it's a 50-question test. And these users have the ability to test new applicants, and they're kind of the gurus in the group, as far as I've been able to tell so far. They're the guys who have the hats with a lot of pins on them, and they know if there's a question you have, these guys will have the answer to it. So that's the amateur extras. Okay, so the U.S. amateur radio bands, in engineering and stuff, we usually use frequencies to talk about radio transmissions and stuff, and we do. I think in most people do, and they talk about, what frequency, um, they were listening to the music on, for whatever channel they were listening to. But in ham radio, they often talk about wavelength, and so they talk about the 2-meter band or the 40-meter band or the 10-meter band, depending upon the meters. That's tied to a frequency range, and they just use that as kind of a shorthand way of talking about the particular section of the bandwidth they're working on for whatever they're doing. And each frequency or wavelength has its own natural abilities and limitations, depending upon, the size of the wavelength, which is obviously directly tied to the frequency. But one of the reasons I think that the ham radio hobby really talks about wavelength so much, especially when they're talking about radio bands, is because wavelength is so closely tied to antenna design, and it makes sense. And depending upon the type of antenna you're using, just depends upon the type of wavelength you're dealing with. So, what are the main types of frequencies? We've got HF, which is high frequency. And in reality, what this really means is it's low frequency compared in the range of what ham radios operators use. High frequency is really kind of a lower range of what they use. And as it's a lower range than what they typically use, it can go beyond the horizon. So it can bounce off the ionosphere, make its way around obstacles a little bit easier. So the next step up is the very high frequency. So a little bit higher frequency, usually line of sight, but it can go beyond a little bit. Has better quality, signal quality, and it's not as prone to interference. And then you got the UHF, which is the ultra high frequency. Definitely it's limited to line of sight, but it can penetrate buildings a little bit easier. Good signal quality, and you definitely can use repeater networks just like you do on the VHF frequencies. So I like this graphic here because it really talks about the HF and why it can go beyond line of sight. It shows the ionosphere, and there's lots of ways that an HF transmission can propagate through the atmosphere. And there's multiple layers in the ionosphere that those who are really into ham radio really understand. And it could be dependent upon the time of day. There's certain things that happen, when it's nighttime versus daytime. Sunspots, not so many sunspots. A lot of things can affect this. So HF, because it's lower frequency, even though they say it's high frequency, because it's a lower frequency in what they use, or what we use today, I guess, in radio transmissions, because of that, it's able to be reflected a little bit easier by some of these things. So it can be reflected across the ground, or as it says here, a surface wave. Lots of things can happen that get some really interesting effects, and you can see transmissions that go thousands of miles, and there's competitions that they try to do that with. So that's HF. Once again, with HF, because it's so prone to being reflected or kind of distorted, it's prone to interference. That natural tendency to be distorted makes it prone to interference sometimes. So there's definitely trade-offs, but it's pretty cool how far it can transmit depending upon the conditions. VHF, UHF, as we talked about before, a higher frequency than the HF, so it's very high frequency or ultra high frequency, and it can't bounce off the ionosphere. But like this diagram shows here, the VHF can make its way around mountains sometimes, and there's some propagation that can occur there, better than it can at UHF. But UHF is going to have the best signal quality, and typically, if you're using UHF, your proximity to the stations will be closer to you. So There's definitely pros and cons to each one, but usually brand new ham operators are going to be using the VHF or the UHF frequencies, as usually the hand radios are using those frequency bands. Okay, so getting into the ham radios, the different kinds of radios, we've got a handheld, which is, like I said, the VHF, UHF. There's the mobile stations, those are the kind you see in people's cars with the big antennas on their cars. You can pick them out a mile away and see those who have ham radios in their cars. And then there's the base station, that's in somebody's basement or in their garage or a room dedicated to it or somewhere else where they have kind of created a station that they plan to keep there for a while. And with some of these different radios, these transceivers, specifically with mobile and base stations, you'll see all frequencies radios. And what that just means is that those radios are able to broadcast and receive on all the frequencies that ham radio operators are permitted to use. Whereas with a handheld, you're limited to typically VHF, UHF, and oftentimes not even all the available bands or frequencies on those two, VHF or UHF. So depending on what someone's trying to do, that radio, that I guess the mission for what they're trying to accomplish, it's going to really drive what kind of radio they get. But the radios can be pretty reasonable. The handheld radios can be as low as $25, $30 for a VHF, UHF, and then it's going to move upwards, at $100 for a decent mobile, and then a couple $100, $300 for an all frequency, and then you'll notice as you talk to ham radio operators, as you get higher up in the cost or the expense level for the radios, your capabilities increase, and I've heard a lot of commentary on the ability to even use all the capabilities, even on a handheld, is difficult. So there's a ton of capabilities out there, and people can keep themselves pretty well entertained by focusing on one and just learning that particular radio and then moving on to the next. But the all frequency ones usually are the most expensive because they can be used for HF, VHF, and UHF. All right, so what are the different modes? So when they're communicating, via ham radio, some of the main ways they do it is with analog. And just like when you're using, FM radio to listen to music, that's an analog signal. There's no digital component to that, and that's where you get your FM from, frequency modulation, or AM, your amplitude modulation. Those are all pretty common. There's some other common ones too that are like single sideband, which is just a modulation technique that uses a section of the bandwidth that's a little tighter or it's on a different side. There's different ways they do that as they experiment with ways to communicate. And then there's phase modulation too. So all those analog ways, they just basically encode your voice or whatever data you're transmitting in a modulation of some kind. It could be an amplitude modulation or a frequency modulation or a phase modulation. But that modulation on the carrier wave is actually what contains information, and so it's just tied directly to that modulation. Some of the other things that different modes are like digital, DMF fusion or D-star, and we're getting back to the zeros and ones, and that's where it's digital. It's communicating differently than analog. And so usually those two don't play very well together, the analog and digital. Fusion's an exception where the fusion can actually, usually those radios are capable of merging the analog and digital together sometimes, which is interesting. But so analog, digital, some other modes that are used are images. So you can actually broadcast images or television, video, that kind of stuff. Data is another one. Data would be like text messaging or files, that kind of stuff. And then finally Morse code, which is really the original amateur mode, which is Morse code. And Morse code, because it is so simple, it requires so little bandwidth that you can get very long ranges with little power, because it requires almost no modulation, since the Morse code itself, the carrier wave being turned on and off, is all that's required. and so no amount of frequency band is very little amount of frequency band is required to carry this Morse code information. So anyway, lots of different things out there, and there is still a large community that uses the Morse code, as they try to communicate long range, with low power, that kind of stuff. But there's lots of different kinds of modes, and amateur radio is just really experimental in the sense that people are experimenting with a lot of different ideas or ways to do it, and so there's a lot more than what I've mentioned here on the modes. But these are the main ones. Most people are using ham radio are going to really drive towards the analog, maybe the digital, but usually the FM is a big one. Sometimes AM, but those are really the big ones. Okay, so what can you do with a license? So once you have your ham radio license, people can do so first-person viewer flying. Oftentimes that image quality is, or that image, that video is actually sent via a ham radio signal, so a license is supposed to be required for that. Emergency communications, if there's a breakdown in communications with cell phone towers become congested, or there's a power failure and you lose the internet and those communication channels like you're used to with your cell phones or with VoIP or those different transmission modes, then ham radio, all it requires is really an operating radio and an operating radio to receive the signal, and that's pretty much it. So it's heavily used in emergency communications. Distant contests, all kinds of contests out there depending upon what they're trying to do, and many times that's tied to their own radio builds. They've got their own kits, or they've made their own designs and create their own radios. You'll also find that in the ham radio community there is clubs all over the place. You can go to online, just search out ham radio club in your area, and it'll bring up the clubs available. But it creates community networking, and a lot of times those networks are used in emergency communications. Some cool features that people do with their licenses, if they're out hiking and stuff, the APRS system allows the ham radio to just transmit GPS location over time. And the APRS system will automatically start that location tracking, and if you're outside of cell coverage, then this could be one of the only ways that you can actually track your location. So it's kind of an interesting function, and that's all been developed by experimental people in the ham radio community that came together and made this function. And so it's just ham radio operators with their handhelds or whatever they're using that's just automatically transmitting location every couple of minutes, and it's done through a digital or through an analog way, and that makes its way into the APRS system, and other people like family and friends can see your progress in your outdoor adventure, or whatever it might be. Satellite communications, so people who are interested in satellites, so they're curious about the science of whatever satellite they're working with. The ham radio communications are often used. International Space Station, big ham radio operator. Emergency weather broadcasting, and then obviously tied to the do-it-yourself radio builds, radio and antenna experimentation is a big area too. So some of the things you can do with a license, I was really surprised at just the amount of really sub hobbies in this hobby. There are just so many different things that people do with this stuff. So, okay, so how do you get a basic license? So it's really not that hard. It's just you find a study guide. There's quite a few free ones out there, but I used, I think it was hamradioprep.com, and I don't get any funding from these guys or anything like that, but it worked okay. They weren't really comprehensive on the ham radio preparation. I mean, there were some things I had to go study elsewhere too to figure it out, but it's a little bit more entertaining. I think the graphics are nice, and they let you take as many practice tests as you want. I think it costs like $25 to get the subscription to hamradioprep.com. You can go to hamexam.org. They've got all the questions in the database that the FCC uses for their tests. You can look through those and study those questions. And it's just a great chance, if you're studying the questions, you're getting a little bit overwhelmed or whatever it might be, it's a great chance to kind of learn about technology and understand some of these things. On the technician level, nothing that they're asking is going to be really too intense. It's really just an introduction to the technology and the science behind the radios. And here's a couple of the free books that I found out there that are just available online for free. So, all right, so taking the test. It's pretty easy to find a place to take the test. You just go to the ARRL, which is the National Association for Amateur Radio. This is the big group that really kind of organizes, the amateur radio section. The FCC creates the rules and regulations and licensing requirements, but the ARRL is really the public interface with a lot of those, with the FCC and stuff. So you just go to the RRL directory, you just put in your zip code or your city, and it's going to bring up all the different exams in the next few months. And there's quite a few, and it just costs $15 to come in and take a test. And so you just look at the particular testing location, and it'll tell you the time and if walk-ins are allowed or if you have to register a call ahead, depending upon what group they are and what they need. So pretty straightforward. You can kind of see what they need. Never hurts to reach out to the proctor just to double check. But you just bring a pencil, your license or passport, and for ID verification. And then if you want, you don't have to, but a simple calculator can kind of help. But they won't let you use any phones or anything complicated like that you could have answers on. Just a real simple calculator. And the math you're doing is pretty simple too, so it's not like you need anything too fancy. But like I said, it's 35 questions, pretty straightforward. Taking the test maybe takes 10, 15 minutes. Okay, so you get your temporary certificate, and you're looking for your call sign because you can't really use your certificate until you get that call sign. So the process will take just only a few days. Once they've processed the certificate, then you'll be able to look at the FCC license database for your name. And it's going to tell you, it's going to pop up, it's going to show you what your call sign is. You're going to see your name, your address, all that kind of stuff, and they're going to see your call sign. So now you want to make your first call. You're interested in actually using this thing, and it's going to likely be on, a pretty easy ham radio, just like a handheld, and probably be on VHF, UHF, and it could be just radio to radio. Maybe you got a buddy that's got, another handheld. You just want to talk to him on the radio. Or you could use a repeater, and that's what I did when I first made my first call, was just a repeater, just to try it out. And but we'll go through that just for a second here, get an idea as kind of how you would use this on a real general, easy level. So a repeater is just an antenna someone's put up somewhere. They've met whatever requirements were required by the FCC to put a repeater up, and that repeater allows you basically to talk to the repeater, and the repeater transmits for you to the area. And the repeater's got a higher watt transmitter than you probably do, or just because of the nature of the repeater. And it's probably on an antenna that's a lot higher too. It could be on a water tower, it could be on a big antenna, but it allows it to go a lot further. So a repeater is a way to really tie in a lot of people, in a bigger area together when their frequencies won't be able to reach each other without the help of a repeater. So the way the repeater works is you can go to, there's websites out there that have a breakdown, like repeaterbook.com, that actually catalog all the repeaters in your area. And you can put in your county, and it's going to tell you all these repeaters. And on the repeaters, it's going to break down all the different information about the repeater and how you're going to use it. And so they're going to see a downlink and an uplink. So the uplink is the way that a user would talk to the repeater. That's the frequency. You're talking to the repeater. And then the downlink is, yes, is the repeater talking to the entire area. So they obviously don't want those frequencies to be the same because it would just clutter each other up. And so you talk on one and it broadcasts on the other frequency. And then the difference between those two frequencies is called the offset. And as you program your first, handheld radio, it's pretty straightforward. Lots of videos out there on how to do that. I may put one on there on how to program a real simple radio. But you just program that offset in, and anything above 147.1 is always going to be a +6 usually. Anything below that, below 147.1 is going to be a -6. So that's how they set the offset is it +6 or -6 off of the downlink frequency. And then you've got the uplink tone or downlink tone. Those are the tones you set in the settings on that particular radio. And that allows you to access the repeater. So the repeater waits for that tone and then knows to now listen and now knows to pay attention. All right, so your first call with, so what's that going to include? So it's real straightforward. You're basically just going to say the station that you're talking to if it's a repeater, or it could be the last two digits of the frequency. So if it's 47.1, then you're just going to say broadcasting or monitoring on 7.1. And that allows other people out there who might be listening to multiple frequencies to know what frequency you're on or what station you're on. And then you almost always end it with your call sign, so they know, okay, this is who you are. And that's pretty much it. As far as all the research I've done and my experience so far, it's just basic common courtesies. You just don't, you let people finish their conversations, and then you try to, let people know that you're there, and people will try to talk to you. And it's pretty straightforward. Most of the conversation is pretty straightforward conversation. It's just that some of the jargon might be you're broadcasting on a particular station and then your call sign. But unlike CB radio, it's a little bit more professional in the sense these people had to get licenses to do it. So as you listen to people talk, you'll be able to see what they use to talk to each other. All right, so some final thoughts. I've talked through a lot of information here, but basically licensing, there's 3 licenses. The first 2 licenses are 35 questions apiece. Last one's 50 questions. You can find places to get licenses online, really easy. the ARRL website. And this opens up a lot of different areas of interest, and then allows people to communicate, whether it's emergency or whether it's just to meet different people in the community. It can be a lot of fun. So anyway, enjoy, and hopefully this kind of breaks down things a little bit and helps it make more sense. Thanks for listening.